Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's natural sciences lesson. My name is Patha Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area planet Earth and beyond. The topic is beyond the solar system, and the subtopic is light years, light hours, and light minutes. Now, let's move on to the lesson objectives. These are the goals that we aim to achieve by the end of today's lesson. At the end of the lesson, you should be able to write the large numbers associated with space distances, explain the concepts light year, light hour, and light minute, measure distance to stars and other objects beyond the solar system, explain concepts of time and distance in the universe, and all this can be found in your CAPS document on page 54. Pre-knowledge. This is what we've learned prior to today's lesson. In the 6th grade, we were introduced to the solar system. And what did we learn in the 6th grade? We learned about systems for looking into space, and we learned about systems to explore the moon and Mars. The moon and Mars. Okay, now let's do the baseline activity. I'm going to read out the questions for you and then give you time to write down your solutions, and then we will do the solutions together. Don't forget to send in your responses to our WhatsApp line, which is at the bottom of the screen. If it is not, it's 08079 578 Now, here are the questions. Write the following figures in numerical form. A, 1000. B, 160,000. C, 1 million. D, 999,000. E, 1 trillion. F, 1,590,720,805,805,000, and then G, 1 billion. I'm going to give you 5 minutes to write down the solutions, and then we will do the solutions all together after 5 minutes. See you after 5 minutes. Welcome back, grade 8 learners. Now let's do the solutions together. Now, we were supposed to write the figures in numerical form. Let's start with A. A was 1,000. How do we write 1,000? It's the digit 1 followed by 3 zeros. The digit 1 followed by 3 zeros. And then B, we're supposed to write 160,000. So it is the digit 1 followed by 6 and 1, 2, 3, 4, 0. So that is how we write 160,000 in numerical form. And then C, 1 million. 1 million, how do you write 1 million? It is the digit 1 followed by 6 zeros, And then 999,000. How do you write 999,000? It is 999 followed by 3 zeros. 999 followed by 3 zeros. And then E, 1 trillion. How do we write a trillion? We write the digit 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. That is how we write 1 trillion in numerical form. And then F, how do we write 1,590,720,805,500? How do you write that whole mouthful? It is the digit 1, 5, 9, 0. So this is 1 trillion. So we're moving from 1 trillion to 590 billion. 720,805,500. That's how we write that huge number. And then 1 billion, it is the digit 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 7, 8, 9 zeros. Okay, I'm going to give you 2 minutes to copy down these corrections, then see you after 2 minutes. Welcome back, grade 8. I'm hoping you had enough time to copy down the solutions. Now let's move on to terminology. These are the important terms that we need to know under this topic. And what are they? The first one is light years. These are units of length used to measure distance between light objects. It is the distance that light travels in a vacuum in 1 year. It is the distance that light travels in a vacuum in a space of 1 year. So that is a light year. And then a galaxy. What is a galaxy? A galaxy is a collection of billions of stars, space dust, gas, and gas held together by gravity. And then an astronomer, this is a scientist who studies stars, planets, and other objects in space. And an example of such is Galileo, who was an astronomer who invented the telescope. And then a star, what is a star? It is a massive ball of burning gas. Remember, the sun is also a star. The sun is also a star. And then universe, this is the entire body of all matter and energy that exists in space. Let's look at the second slide. We have more terms. Constellation. Constellation is a group of stars that when we view them from Earth form a pattern in the sky. And the ones that are very famous are Orion, Ursa Minor, Ursa Major, Taurus, and Gemini. And then Alpha Centauri, this is the name of the closest easily visible star after the sun. So there are other stars that we are able to see in the sky. There are other stars as well. Okay, now let's talk about light years. So when astronomers are measuring a vast distance, they use light years, light hours, and light minutes. So these are the units that they use when they are measuring a vast distance. Now, even though a light seems like a unit used for measuring time, a light year measures distance. So we'll be measuring the distance between the Earth and the Sun, the distance between the Earth and the other planets in our solar system, and the distance between the Earth and other stars which are not in our solar system. So I'm going to pull up a picture here just to show you an example of what we mean by we use light years, hours, and minutes to measure distance. If we look at the distance between the moon, remember we have our own moon. The distance between our moon and us is 1.3 light seconds, so which means our moon and us is not very far from us. And then the distance between us and the sun, us meaning the earth, the distance between the earth and the sun is approximately 8.3 light minutes. So that is the distance between the earth and the sun. And then the distance between the Earth and Proxima Centauri. Remember, we learned about Proxima Centauri and the Southern Cross in our previous lesson from last week. The distance between the Earth and the Proxima Centauri is 4.2 light years. 4.2 light years. So this is just to show you that how astronomers they measure vast distances, that are very, very great numbers. Okay, so what exactly are light years? So light years are units of length that are used to measure the distance between light objects. So it is the distance that light travels in a vacuum in 1 year. Remember, we're introduced to light when we're learning about the spectrum of visible light in term 3, when we're learning about how light travels in straight lines, or how we get our white light from the sun. So light has the fastest speed that we know. It is faster than sound. That is why you're able to see the lightning in the sky when there's a thunderstorm, and then you hear the thunder after. So the lightning strikes first, so you see the light, and then you hear the thunder second, because light has the fastest speed that we know, and it is capable of traveling about 7 times around Earth in just 1 second. Can you imagine how fast the light is? So 1 light year is said to be approximately 5.88 trillion miles. That is quite a vast distance, or 9.5 trillion kilometers. Some textbooks may tell you that it's about 10. Now, that is 1 light year. That is 1 light year. The distance traveled by light in 1 year is about 9.5 trillion kilometers. It is very fast. Can you imagine how long it would take us humans to travel that distance? Now, when we look at the Milky Way galaxy, which is the galaxy where our solar system or the Earth solar system is found. So the galaxy, the Milky Way galaxy if we measure it across like that, this is 100,000 light years. The distance is 100,000 light years if we were to measure that distance. Now let's talk about light years, light hours, and light minutes. The Proxima Centauri is said to be 40 trillion kilometers from us, away from us. Who is us? Us is the Earth. That is where that star is said to be. That is quite a very, very long distance. These numbers are astronomically large. These are very large numbers. As you saw when we were writing the baseline activity, that these are very, very large numbers. These numbers are huge. We have to put like lots of zeros in front of the one. So these are very, very large numbers. So because of these numbers being so large, astronomers don't use kilometers. You hear them using terms light minutes, light seconds, light hours. You hear them using such terminology. They do not use kilometers because these distances are very large. So they don't use kilometers to measure the distance to the stars, but they use larger units based on the speed of light called the light year. The light year, the distance traveled by light in a space of 1 year, in a space of 1 hour, in a space of 1 minute. Okay, so let's try and visually look at this concept that Proxima Centauri is 40 trillion kilometers from Earth. So this is the planet Earth, our planet, the planet that we live on. This is planet Earth, and this is Proxima Centauri, a star. Okay, so it is said to be 40 trillion kilometers approximately. That's why there's this sign there. Approximately 40 trillion kilometers from the planet Earth. But astronomers won't use trillion. They will use approximately 4.2 light years. So that is the unit that the astronomers use. That is the unit of measure that the astronomers are going to use. Now, let's talk more. So a light year is the distance that travels in 1 year. We have established that light travels in 1 year. So that is what we call a light year. The distance traveled by light in a space of 1 year is a light year. So 1 light year is about 10 trillion kilometers. That is a very long distance. Imagine you traveling 10 trillion kilometers. How long would it take you? How long would it take you? But for light, it takes light 1 year to cover this distance. It takes light 1 year to cover 10 trillion kilometers. So light is indeed the fastest speed that we know. The speed of light, very, very fast. A light hour is the distance that light travels in a space of 1 hour. So that is what we call a light hour, the distance that light would have traveled in 1 hour. And look at that. So now the speed of light is said to be approximately 299.792 kilometers per second. Now, if we look at the distance between the Earth to the Moon, the Earth to the Sun, about 8 light minutes. The distance between the Earth to the Moon is approximately 1.29 seconds. The distance between the Earth to Mars, remember Mars is one of the planets that are found in our solar system, one of the 8 planets found in our solar system. So if you were to want to venture to Mars, that would cost you 12.7 light minutes to go to Mars. 12.7 light minutes to go to Mars. And then if you want to go to Proxima Centauri, our nearest star, we have said it's about 4.2 k's, 4.2 light years, 4.2 light years. And then if you want to travel to the other side of the Milky Way galaxy, that will take you 52,000 light years. 52,000 light years. That is quite a distance. It supersedes the human lifetime. It supersedes the human lifetime. Okay, so now let's dive into an activity. So I'm going to read out the questions to you, and then I am going to give you time to answer those questions, and then you need to send your solutions to 079 578 2908, which is our WhatsApp number. All right. So now let's compare the terrestrial and gas planets. Study the information in the table below and answer the questions that follow. Now we've got a table here, and the table has 1, 2, 3, 4, 5, 6, 7, 8 columns. And the headings of these columns are name of the planet, and underneath we've got the planets of our solar system. Density, this is kilograms per cubic meter. Then we have the density of each planet in that column, and then we have size or diameter in kilometers. So we've got the size or the diameter of each of the planets in our solar system, from Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Then afterwards, we have distance from the sun in millions of kilometers. So we've got them from Mercury all the way to Neptune. And then we've got another column, the number of moons that each of this planet has. Of course, we have one moon, and then the other moons that the other planets have. And then we have surface temperature. So this is the temperature at the surface, the average surface temperature of each of these planets. Mercury has 167 degrees Celsius, all the way to Neptune that has minus 200 degrees Celsius surface temperature. So it's very cold. And then we have day length and in hours from Mercury to Neptune. And then we've got year length, which is counted in Earth days. So the first question is, which type of planet tends to have the shortest day? So you need to retrieve that information. The second question is, what does this tell you about how fast the two types of planets rotate on their axis? The third question is, which planet orbits around the sun the fastest? Explain your answer, and then which planet's year is shorter than its day? I'm going to give you 5 minutes to answer these questions. Then after 5 minutes, we will do the solutions together. See you after 5 minutes. Welcome back, grade 8 learners. Now we're going to do the solutions together. Now the questions read, which type of planet tends to have the shortest day? What does this tell you about how fast the two types of planets rotate on their axis, and which planet orbits around the sun the fastest? Explain your answer. And which planet's year is shorter than its day? So you're supposed to extract this information from the table. You're supposed to extract the information from the table. So which type of planet tends to have the shortest day? So the gas giants tend to have the shortest day from the information that was shown, the gas giant. And then what does this tell you? So now that we know that the gas giants tend to have the shortest day, what does this tell you about how fast the two types of planets rotate on their axis? How does it show you? So it shows you that these planets must spin on their axis faster than the terrestrial planets. So they have shorter days. Remember, our day is 24 hours long, and it takes the planet Earth 24 hours to complete a rotation on its axis. So which means our day is 24 hours long. So if the gas giant's days is less than 24 hours, it means that their days are shorter than ours. Their days are shorter than ours, which means their rotation about or around their rotation on their axis takes a shorter time. They take a shorter time in comparison to the terrestrial planets. And then which planet orbits around the sun the fastest? Explain your answer. Mercury. Mercury is the one that orbits around the sun the fastest. This is because it is the closest planet to the sun and has the least distance to cover. It is the closest. Remember, the Earth takes 365.25 days to do a complete revolution around the sun. Remember, we call it a revolution. The earth revolves around the sun. It takes it 365.25 days, which is our year. Mercury, however, takes a shorter time. Why? Because it is the closest to the sun. If you look at the order in which our planets are in the solar system, you will see that Mercury is the closest to the sun, followed by Venus and then Earth. So naturally, it would take Mercury a shorter time to complete its revolution around our sun, which makes Mercury the one that has the shortest year. And then which planet's year is shorter than its day? And it is Mercury. Mercury's day is longer than its year. I'm going to give you 3 minutes to copy down these corrections, then see you after 3 minutes. Welcome back, grade 8 learners. I hope you had enough time to copy down the corrections. Now, let's move on. So, our solar system has a diameter of about 13 light hours. So, there's a diameter of about 13 light hours. So, a light minute, remember, is said to be the distance that light travels in a space of 1 minute. So, that is a light minute. And the Earth is about 8 light minutes away from the sun. So it takes 8 minutes from light from the sun to reach Earth. It takes 8 minutes from light from the sun to reach Earth. But let's look at the other planets that are in our solar system. So we said it's approximately 8 light minutes for light from the sun to reach our planet. Where's Earth? There is our planet Earth. So it takes about 5.10 light minutes for the light to reach Mercury. The light from the sun to reach Mercury takes about 8.10 minutes. Then it takes 2.3 minutes for the light to reach Venus, 4.35 minutes for the light to reach Mars, 35 minutes for the light to reach Jupiter, 70.8 minutes for the light to reach Saturn, 2.5 hours for the light to reach Uranus, and 4 hours for the light to reach Neptune. All these are light minutes and light hours. The distance that it takes the light to travel from the sun all the way to the planet Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, and Mercury. So these are the distances traveled by light that is coming from our sun to the different planets, Now let's bring this concept closer to home. So these are the distances traveled by light. So in 1 second, think of 1 second. In 1 second, light can travel between Cape Town and Johannesburg 214 times. 214 times. That is a second. That is in 1 second between Johannesburg and Cape Town. So which means light is going to be able to take 0.0000003 seconds to travel a distance of 100 meters. A distance of 100 meters. And then so light in 1 second, light can travel between Cape Town and London, which is in England, which is overseas, 31 times. So that is in absolutely 1 second. Light can travel 31 times between Cape Town and London, which is in England, in a distance of 1 second, 31 times. And light takes 1.3 seconds to travel from the Earth to the moon. Just compare those two. So if it's going to travel 31 times between Cape Town and London, so which means about in a space of 1 second, and then our planet and the moon, the light takes 1.3 seconds. Can you think about that distance? So light takes 1.3 seconds to travel from the moon to the Earth. And then in 1 second, that light would have traveled 31 times between Cape Town and London. Compare those two differences. And then in 1 second, light can travel around the Earth 7.5 times. It can travel around the Earth 7.5 times. And light takes about 8 minutes to travel from the sun to the Earth. It doesn't take long to travel from the sun to the Earth. Okay, now let's move on to our second activity. Here we're supposed to plot a bar graph to show the distance each planet is from the sun. Plot a bar graph to show the distance each planet is from the sun. So you take this information on the table and then draw a bar graph. I'm going to give you 5 minutes to draw this bar graph. Then after 5 minutes, we will draw the graph together. See you after 5 minutes. Welcome back, grade 8 learners. I hope you have drawn your graph. Now let's go through the question together. So the question reads, plot a graph to show the distance each planet is from the sun. So we needed to use information that is on the table to draw the graph. And what kind of graph is it? It is a bar graph. Step number 1, you need to know which graph you need to draw. And the graph that you needed to draw is a bar graph. And what is our graph going to tell us? What is our graph going to tell us? It's going to tell us how each planet from our solar distance, how far each planet from our solar system is from the sun. So we need to know where we're going to get this information. So information number 1, we need one of our axes has to have the names of the planet. Which planets are we talking about? We are talking about Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And then we need another set of numbers. We need more information because remember our graph has an x and a y axis. So where's the next information? We need distance from the sun. So let's check the columns. This one is density in kilometers, in kgs per cubic centimeter, cubic meter, sorry, density in kgs per cubic meter. That's not what we want. We want distance. The next column is size or diameter. That's not what we want. And then this is the column where we're going to get our information from. This one. This is the column where we're going to get our information from because it tells us the distance from the sun. And it also tells us the units that we are supposed to use. So Mercury is 5.79 millions of kilometers from the sun. Venus is 108.2 million of kilometers from the sun. The Earth is 149.6 millions of kilometers from the sun. Mars is 206 millions of kilometers from the sun. Jupiter is 740.5 millions of kilometers from the sun, and Saturn is further from the sun. It is 1,352.6 millions of kilometers from the sun, and then Uranus is 2.3 millions of kilometers from the sun. And then we have Neptune, which is 44444.5 millions of kilometers from the sun. So that's how far it is. So it is far. It is far. So now this is the information we're going to use from here and information from here to draw our bar graph. So now let's move on to the next slide to show you how I drew the bar graph. So this is the solution. So remember the bar graph. A bar graph is the one that has bars. So this is our bar graph. Your graph has to have a title. Your graph has to have a title for you to get marks. So I've given mine a heading or a title saying bar graph showing distance of each planet from the sun, and the distance is recorded in millions kilometers. The distance, so these are the units that we're using. The distance is shown in millions kilometers. So now this is our x-axis there at the bottom, and then we have our y-axis. Okay, so on the axis, this is where I'm going to put the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, the 8 planets that are in our solar system. I'm going to put them on the x-axis, and then the y-axis, we're going to put the distance from the sun in kilometers. Of course, you saw the distances from the sun in kilometers. They had commas, but we need to put the values in whole numbers. So we've got 0, 500, 1,000, 1.5. So we are putting them in 500 gaps. Now, so Mercury is the one that is actually the closest to the sun. So naturally, its bar is going to be the shortest, followed by Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So I'm going to give you 4 minutes to draw this graph. To draw this graph, make sure you get your units on the y-axis and the names of the planets in the order in which they are from the sun. I'm going to give you 4 minutes to draw this graph. See you after 4 minutes. Welcome back, grade 8. I hope you had enough time to copy down the bar graph. Now let's wrap up our lesson. What did we learn today? What did we learn in today's lesson? We learned that we use light years, light hours, light minutes to measure vast distances. Which distances are we talking about? We are talking about the vast distances between the Earth, the other planets in our solar system, the distance between the Earth and our Sun, the distance between the Earth and other stars. These distances are quite big. They are huge distances. For example, the star Proxima Centauri is 40 trillion kilometers from Earth. So it is easier to say it's 4.2 light years. So we use light years, light hours, light minutes to measure vast distances. We are 150 million kilometers from the sun. But if we measure in minutes, if we measure in light minutes, we are 8 light minutes away. Right, what else did we learn? We learned that one light year is the distance that light travels in the space of a year. So the distance that the light has traveled, let's say from the sun to the earth, in a year, we call that one light year. So that is the distance that is traveled by light in a space of 1 year. The year, of course, is the earth years. And one light hour is the distance that light travels in a space of 1 hour. So we're measuring how long it took the light from a certain point, maybe point A, all the way to point B. So that is 1 light hour. And then 1 light minute. This is the distance that light travels in the space of 1 minute. Remember, we are 8 light minutes away from the sun. So the sun takes 8 light minutes to travel all the way to the earth. The light takes 8 minutes to travel all the way to the earth. That is a very short distance, considering if you convert it to kilometers, how far we are from the sun. If you convert it to kilometers, we are very far from the sun. So in our next slide, I've got the homework activity. I'm going to give you 2 minutes to copy down all the questions for the homework activity. So see you after 2 minutes. Welcome back, grade 8 learners. Now we have come to the end of our lesson. In the next lesson, we're going to be learning about beyond the Milky Way galaxy. So you can read ahead. This is what we're going to be doing in our next lesson, next week, Tuesday. And then here is a reminder after you are done watching the lesson, after this lesson is over, don't forget to click on this button here that says complete and continue. Don't forget to click on the complete and continue button. Until next time, please stay safe and bye bye.